My work within electron spectroscopy is about understanding more about lithium-ion batteries and how they work. Especially I have been looking at the interfaces in a battery and try to understand what reactions that are occurring there, and with a particular focus on the degradation reactions. So what is occurring when your battery gets worse over time, essentially. If we talk about lithium-ion batteries, I think what we need is batteries that last longer, like the lifetime, and also that can store more energy. There we can do quite a lot by better understanding these interfaces to try and then limit the side reactions that cause the battery to degrade in the end. I'm probably most proud of having been a part of developing a methodology for doing operando measurements of lithium-ion batteries. And that means that we can measure the battery while we are cycling the battery. So this is made possible by instrument development that has been occurring during the last 10-15 years. To further develop the lithium-ion batteries and using photoelectron spectroscopy, I think there are two important aspects, the lifetime and the energy density, where photoelectron spectroscopy can be used. And in the first time, for the lifetime, I think it would be more specific measurements, looking at the interface, understanding the degradation reactions, why the battery is degrading over time. And the second would be more large screening, looking at all the different materials combinations and trying to find the optimum, where also photoelectron spectroscopy would be really useful. I'm probably biased, but I think photoelectron spectroscopy is a really great technique for studying batteries or electrochemical systems in general, because it has these chemical sensitivities, so we can look at the atoms, the redox states of the atoms, but because we're looking at electrons, we can also look at the potentials. So this is super important for a battery, because you want to know what happens when you change the voltage, what are the voltage in different parts of the battery. And this we can do at the same time with photoelectron spectroscopy. And it's not a lot of other techniques that we can do this with. So I think that's really beneficial for studying, for example, batteries.